1C on vectors is titled the unit vector and direction angles. So anytime you see unit, like we had the unit circle, now we're having the unit vector, it's going to have a length of 1. And there's this little formula where you're going to have v over the magnitude of the vector. So to find a unit vector in the direction of v, it's going to be 1 over the magnitude times v, or simplify it to v over the magnitude. Then the next box says I and j. Whole new thing in this box are useful vectors in the coordinate plane. I is along the positive x-axis, so I is going this direction. This picture is not good, cross it off. Going this positive direction, so 1, 0. And j is positive going on the y-axis, going 1 unit this way. And any vector can be written in terms of I and j. So the vector 2, -3 can be written as 2i minus 3j, and they call it a linear combination. In the next box, they want us to find the unit vector in component form in the direction of v and as a linear combination of I and j. So the first one, they give us the vector v, and it is 3, -4. So the first thing we're going to do is we're going to find its magnitude, because we need that. So we're going to take the a value and square it, so 3 squared for this one, plus the b value of -4 and square it. So 3 squared is 9, -4 squared is 16. 9 plus 16 is 25. When we take the square root of it, we get 5. So to write it as a unit vector, we take the actual value over the magnitude, so we call it 3 over 5, and we take the vector -4 and put it over the magnitude of 5. So as a unit vector, it's written like this. If they ask you to write it as a linear combination, you just take the first value I and then the second value j. All right. Sometimes when you take the magnitude, your square root does not simplify completely, right? So you end up with something under that radical. And so when you go to write it as a unit vector, you can't have that radical in the denominator, so you have to rationalize that denominator. It's like a pre-algebra thing you learned. So for number 2, the first thing we want to do is get the magnitude. So we take the a value and square it, so 1 squared is 1. We take the v value and square it, so -2 squared is 4. And then when we add 1 plus 4, we get 5. But when we go to take the square root of 5, it's prime. So it has no, it's not going to simplify, right? So if we were going to write it as a unit vector, we would want to say 1 over the square root of 5, except you can't, because you can't have that radical in the denominator. So you have to rationalize that denominator by multiplying it by rad 5 over 5, which puts the radical 5 in the numerator and the 5 in the denominator. And believe it or not, that might be the trickiest part of this whole thing, is remembering to rationalize that denominator. Okay? That's writing your answer as a unit vector. If they ask you to change it to a linear combination, you're just going to add the I and the j. If this was positive, this would be plus. So they both just happen to be negative. So it's minus, but that's what that is. Okay? Any questions on those 2 examples? Do I need to move it up a little? Okay. The bottom at the box is talking about direction angle. So it says a direction angle is the angle a vector makes with the positive x-axis. Any vector can be written using the magnitude and direction of the angle. For example, we're going to take the magnitude times the cosine of the angle. You're going to either be given a measure or you're going to be given a ratio, like maybe off of your unit circle. But for right now, you're going to be given an angle. So cosine is going to come first, and then the sine is going to come second. Let me show you what that looks like on the next page. So if you flip over to the back of the page, it gives you the information that you're going to need. Okay? So they want you to find the component form, something x, something y, of the vector v. And then it gives you the information you need to calculate it. So the angle is 50, and the magnitude is 22. So if we take the form from the previous page, which was the magnitude times the cosine of the angle, and then the magnitude times the sine of the angle, you simply plug in those numbers. So the magnitude was 22, the angle was 50. The magnitude was 22, the angle was 50. Then you type it into your calculator. Make sure your calculator is in degree mode. If it's in another mode, you're going to get the wrong answer. Okay? And if you need help figuring that out on your calculator, let me know. But let me show you how to type it in. It's pretty easy. So for the 22 cosine of 50, let's turn the calculator on. 22 cosine of 50 degrees. Hit enter. We're going to round it. Oh, and there's a glare. Round it to 14.1. And then we need the 22 sine of 50. And that one I rounded up to 16.9.